Or wait.
So I'm going to draw this right here. So pretend this is our X and Y axis. And then gravity comes off at a 20-degree angle. And we want to find that piece right there.
Oh.
So this is FGX.
Okay. So it would be cosine. It would be like FGX cosine. Oh, FG cosine is 20 degrees.
Yeah, that's close. But cosine would give you which side, the adjacent or the opposite.
The opposite. Or the adjacent.
Yeah. So cosine would actually give you this side.
Oh, so you want the opposite.
Yeah, you want this one.
So sine.
So this is where it changes. Typically when we were doing vectors, we break them down like this, and the angle would be here. And our x would always be with cosine, and our y would always be with sine. Now, that's not always how it is, so you just have to watch your angle and make sure.
Okay. So on this one, since the graph is like tilted, there's a scale, it's pretty much like the opposite than what we went through, what we went over probably like 2 times ago or something. Is that right? So like, instead of x being cosine now, y is cosine, x is sine.
Right. Yeah, the reason for that is because of where our angle is drawn.
Right, okay.
So we know this angle, that's the angle that we know because of the incline. So we just stick with using it. But when we draw it out, this is our hypotenuse. And then the x is opposite of our angle, and the y is adjacent to our angle. So we were given an angle that is next to the y-axis, right?
Right.
So if we're given an angle that's next to the x-axis, say you could have the same problem, but maybe the truck was pulling the car at some angle. So you'd have your free body diagram, and this force would go like this. Maybe this was a 20-degree angle.
Oh, and it's on the x-axis, so it will be cosine.
Yeah. Yeah, so just check every time to make sure you're using the right trig functions. So this would be TR minus 15,000 times the sine of 20 degrees. And that equals what? So this is so we don't know what TR is yet, but the sum of the forces in X, the net force in X, is going to be equal to what?
Forces x.
Remember over here?
Equals 0.
Yeah, so if there's no acceleration, that's going to end up being equal to 0. So this is our force equation. This is how we figure out our net force. And this is our acceleration.
Okay.
Well, our mass times acceleration, but if it's 0, it'll be 0. Okay? So then we can do the same thing with y. So the forces of y equal what?
Zero. Or is that?
Yeah, so they will equal 0. But what do they equal in our free body diagram?
It would be 15,000 TR.
So you just want to look at the ones on the x-axis? So this is the normal force.
So Fn.
Force normal.
Be positive 6,000, or is it negative?
For this one?
So do you put like the TR, the tension of the rope in it too?
No, because this is directed along the x-axis, right?
Oh,
So we just want to look
Y.
at what's in y.
okay.
So this one's on the y-axis.
So Fn minus 15,000 cosine 20 degrees.
Perfect. Okay. So this is what's called the sum of the forces in Y. This is the sum of the forces in X. And when they all add up, they have to equal 0. So now we can solve for our normal force pretty quickly, because it would have to be,
0.
yeah, you just solve for normal force. But we're not really worried about the normal force. What we're worried about is tension. So what would the tension be in this rope when you solve for TR?
Well, you add 15,000
Mm-hmm.
sine 20 degrees on the other side, and that will equal your TR.
Okay. So then you find out this number. What is that?
Is 5130.3.
What's the units?
Pounds.
So this is the tension. If you're doing this, you're pulling your car up the hill, 20-degree angle, it's a 15,000 pound car. Then this would be the tension in the rope.
It would break.
Well, the max is 6,000.
Oh,
So we're pretty close to the max. We're about 870 pounds away.
okay. So that's the tension. That's okay.
Right. So what it's saying is, as long as this number, the tension that's actually in the rope, is less than our maximum, then we're good.
I was thinking that was like the pounds that the rope holds the tension.
No. So this is what they give you
Right.
as the maximum amount it can hold,
Okay.
and then you find out yourself from this reaction right here
How much tension is?
how much tension is actually in the rope. So that's how much tension's in it. So what about if we were to try going up a steeper hill?
Tension we get over here.
Yeah, because you're having to pull more of that force of gravity because your angle gets bigger. Then what if you're just maybe flattened it down and started driving on flat ground?
Or we get less.
Yeah, exactly. So as long as if this hill goes and you're just going along and it gets a little steeper, you're probably gonna break your rope. But if it never gets any steeper than that, then you're good. And also if you never try to accelerate. So in reality, this probably wouldn't work because you're so close. This is if you're just at a standstill, if nothing has moved yet, or if you're moving at constant speed. But in order to get to a constant speed, you've got to accelerate somehow. And that's going to put more tension on that rope, which will probably break it. But
That would sting.
in the eyes of the problem, you're probably good. So, real quick for this kind of a problem, circling it and like finding all the reactions and stuff, you don't have to do that. It's just sometimes a way to make sure you don't miss forces, because when you draw your free body diagram, you're going to have forces coming off of it all over the place. Maybe you'll have a friction force. Maybe somebody will be pushing it or pulling it with a rope. Like, there's all kinds of things that could be happening. And so they have you circle it to make sure you get all of them. But you just get pretty good at recognizing what will be there. There'll be a normal force from the road pushing back. There's going to be a tension force. There's going to be gravity. So you kind of draw a picture, figure out what's going on, draw a free body diagram with all the forces on it, and then you sum your forces in X and then Y. So you break down any forces that aren't on the axis, you add them all up, set them equal to 0, or say your acceleration was 2, then you set it equal to that. You find mass times acceleration, set it equal to that, and then solve it for what you have unknown. So right at the first, they're kind of like it's just a totally new thing, but these kinds of problems aren't too bad. Actually, I'd rather do forces than kinematics because they're easier.